Let's talk about logic gates. So the logic gates make up circuits, and the collection of these logic gates, as you learn about the fundamentals, is you'll find that once you create a circuit, you can actually create a mathematical operation out of these logic gates. But you first need to learn the fundamentals. The first gate that I want to introduce you to is called the AND gate. Now each gate is going to have something called a truth table. The truth table tells you the behavior of the gate based on its inputs. For example, the AND gate, when both inputs are 1, will always give you a 1. When both inputs are not 1, then it will always give you a 0. Now if you create a truth table for this AND gate will have 4 rows. It will have all possible values for A and B and all possible output. So for example, you'd have one row that says 1, 0, then 0, 1, 1, 1, and 0, 0. Depending on how you write them out, it really doesn't matter. It doesn't make a difference. You should know that the rules for this AND gate is when both inputs are 1, then the outcome will always be 1. And when both inputs are not 1, then the outcome is 0. Okay. So these are the rules, but based on these rules is when you create your truth table. So your truth table, even though there's only 2 possibilities here, your truth table contains 4 rows. Next gate is called the OR gate. Again, the OR gate uses 2 inputs and it generates 1 output. Sorry about that. Now the rules for the OR gate are a little different. This particular OR gate has a couple of rules, and we can write out a truth table for this. When both inputs are 0, then the outcome is going to be 0. That's a given with an OR gate. When one input is 1, or both inputs are 1, then the outcome will be a 1. What does that mean? So if we write out the OR gate values for inputs, let's say input A was 1, and input B was 1, then your output would be 1. If input A was 1 and input B was 0, your outcome is still 1. And you reverse that, and that's actually the same value. So if input A is 0 and input B is 1, then your outcome is still going to be 1. So the only time that the output of the OR gate is 0 is when both inputs are going to be 0. So if you were going to write out a truth table for this, you'd have 4 rows because you only have 2 possible inputs. And you would write out all possible values for inputs A and B. And following the logic of the OR gate, you would write out the output values. The last gate that I'm going to go over is the NOT gate. Now this gate is different than the others because number one, it has only one input. It still generates one output, but because this gate only has one input, you can only have a value of 1 as input A, or you can have a value of 0 as input A. If you plug in the value 1 in input A, it's going to give you the inverse of it. So when the input is 0, the outcome is going to be 1. When the input is 1, then the outcome is going to be 0. In the truth table, you're only going to have 2 rows because all the possible values of A is either going to be 0 or 1. So the more inputs you have, the more rows you're going to have in your truth table. There is actually a formula for your truth table rows. So it's actually 2 to the base of your input values. So if you have 2 inputs, then in your truth table you're going to do 2 to the second power, and that gives you 4. So that means your truth table is going to have 4 rows. If you had 3 inputs, then you're going to do 2 to the third power, or 2 cubed, which is going to give you 8 rows. The exclusive OR gate is also, it's a little different than the other gates because the outputs are a little weird when it comes to the inputs. So it still uses two inputs and it generates one output. And the rules are as follows. When the input values are equal, then the outcome is 0. When the input values are not equal, then the outcome is 1. So the logic goes that it doesn't matter what the values are per se, just as long as they're either equal or they're not equal. So I'll give you an example. If we were writing a truth table for this, again, you're going to have 4 rows, 2 to the second power, because you have 2 inputs. It means that if you have the value 0, 0, then your output is going to be 1. Or if you have the values 1, 1, then your output's still going to be, your output's going to be 0. So 1, 1 will give you 0. 0, 0 will give you 0. If you have 1, 0, then the outcome is going to be 1. If you have 0, 1, then the outcome is going to be 1. So again, the logic of these gates, it doesn't depend on the values, it depends on the logic of the actual gate. So again, in this particular gate, the logic is that when they're both equal, the input values are equal. So if A and B are equal to each other, then your output's always going to be 0. If there is a difference of values between A and B, meaning that it's either 1, 1, 0 or 0, 1, then your output's going to be 1. And that's it for the logic gates lecture for this. I'm sorry I did mention that the NOT gate was the last one, but it's not. It's the exclusive OR was the last gate that I was going to go over. So once you know these and you're able to write a truth table, all these become very, very easy. So let me give you an example of how to write a truth table. So if I add another slide, all I have to do is just create a table. So for example, I'm going to do a truth table that has 4 rows, and we do it should be actually, let me delete this. If we insert a table, we're going to do 4 rows, and we do that. So we have the input A and the input B and then the output. We write out all possible combination of values. So 1, 0, 0, 1, 1, 0, and 0, 0. Now let's say we were doing a AND gate. So let me just put in a text here. So AND gate. So what are the rules for the AND gate? Well, the AND gate tells you that the only time that the output is 1 is when they're both equal to 1. Correct? So actually this should be 1, 1. Sorry. So where is the row where the inputs are all equal to 1? That's right, it's the third row. So the third row is going to have the value of 1. Everything else is going to have a value of 0. And what I mentioned before is that if you have a inputs, meaning you have A is one input and B is one input, as long as you have the number of inputs and you know them, then all you have to do is say, okay, 2 to the second power, that's going to give me 4 rows. If I had 3 inputs, okay, then I would have to do 2 to the third power, and that would give me 8 rows. Okay, so this table will no longer, this truth table will no longer have 4 rows, it would actually have 8. So the more inputs you include, the more rows you're going to get. Let's see if you can write a truth table for the OR gate, the NOT gate, and the exclusive OR gate. Please try that. Thanks for listening.